Hello everyone, today we discuss contest 22. Very interesting contest. I would say pretty hard. Last three problems. Like you see, I made some mistakes solving all three of them. Especially the last problem is very fun. So last problem is difficult, but it's not about any special data structure, not about special algorithm. It's just pure algorithmic problem. I would say some ad hoc constructive something like this problem. So I spent some time solving this problem, and it was kind of fun. So let's see. I pre-recorded myself like usually I do, and we will watch how I solved all these problems one by one. So start from problem A. Problem A is pretty straightforward, so you just do what you need to do in this problem. So you need to find the last letter and check if it's vowel or consonant. So like again, it's all written in this problem statement. You just do what's written. Okay, you may have technical difficulties in this problem if you never did something like this before. So first of all, you need to read the whole string, the whole line with spaces and stuff. I always forget how to do it in C++, so again, I spent some time trying to figure out how to do it. Okay, I'm not that good in technical C++ problems. So when you need to do something like text analysis, like stuff like this, I don't usually do it in C++. So I always forgot how to do it. Then I tried to do it in most simple way I can do it. So I reverse the string and then just iterate all characters and try to find the first character, which is a letter. Okay, I try to find a specific function is letter. Maybe there is some function. Okay. Okay, if you good in C++, you maybe know how to do it in a single line, but I don't know. So I just check if this character is between A and Z. And there it may be capital letters, so you can check if it's between capital A, capital Z. If it is, then you have a letter. Then you need to check if it is vowel or consonant. So I do it like this. Okay, I do it very strange way. I spent too much time solving this problem, but that's because I'm not I'm not that good in technical problems in C++ because I don't normally write programs like this in C++. Like no, not that many people do, I would believe. So I just try to find some way to solve this problem, and I'm spending too much time trying to because I want to show this code to you. I try to make some beautiful code. Yeah. Normally, I would just make very ugly code, and it probably I will spend less time solving this problem if I allow myself to write very ugly code. Okay, here I forgot how to what. So I know there is function find in C++, which look up for the character in a string, but I forgot how to use it. Okay. So at some point I actually Googled how to do it. That's okay. Okay, you don't have to know everything, you know. So if you forgot something, just Google it. It's okay. Important thing, I learned something new today. So I know that if you didn't find anything, you return something like string and pause. Okay, why not? So if it's not in pause, then I found the character. And if this character is in the string, yeah, I found yes. I'm not proud of this code, but it works. Okay, it's most important part. That's it. That's it. So I find the last character, which is a letter, and check if it belongs to this set of vowels or not. Okay, nothing interesting about this problem, just the first problem to start with. Okay, so you just spend as little time as possible solving this problem and then move to the next one. Okay, so let's go to problem B. Problem B is another pretty straightforward problem. It's a little bit more complicated, but still nothing interesting. So you have 4 guards you need to bribe. For each guard, you can buy a chocolate or a juice, and for each one you know the minimal price. And your question is to find the minimal possible bribe you can get. And if you have 4 posts, in each post you have 2 guards. Again, too many details in this problem is just to make you spend some time reading all these details and carefully implementing all it. But the idea is pretty simple. So you iterate all these posts. For each post, you find the minimal amount of okay, and you don't want to spend minimal amount of money. You need to spend exactly uh, n amounts of money. What you measure money in? I don't know. So you want to spend exactly n units of money. Okay, but you're allowed to spend as much as possible as many units as you want. So again, what I will do, I will find the minimal amount of money to spend, and then if I need to spend more money, I will just spend more money. Yeah? You can always spend more money if you want to. Okay, let's speed up a little. Too slow. Okay. So normally I just I just read all the data in this double array, but here I do what I'm doing. Yeah. So here x and y is the minimal amount of money I need to spend for the first and for the second guard. See? And then I check if this amount of money is less or equal than n, then I can do it. So I can spend n units of money for these two guards. I will spend x for the first one and n minus x for the second one. Yeah. So the sum is n, and n minus x is at greater or equal than y. Yeah, because of this. That's it. So if no, then I will just report -1. Yeah. I don't like this problem that much, but again, you don't need to like all the problems you solve. Yeah. So you just read the problem, do what need to be done, and move to the next one. So again, the important part, if you don't like some problems in the beginning, it's okay. You just solve them and then move to interesting problems. We will get to interesting problems. Problem C, for example, is kind of interesting. So in problem C, you need to find the maximal segment which forms some kind of Fibonacci sequence. Yeah. So each next element is sum of two previous elements. If you have less than 3 elements, then it's correct Fibonacci sequence. So any sequence of length 1 and 2 is correct Fibonacci sequence. Yeah, I will do it like this. So I will find the maximal number of consecutive elements such that each of them equals to sum of two previous elements. So my answer will be 2 plus number of elements equal to the previous one. Let me show you. Let me show you. Let's clear this. So if you have some segment, yeah, so you may have any elements here, yeah, but each of the next element should be a sum of these two. So this is sum of these two, this element is sum of these two, and so on. So we don't know anything about these two elements, but for each of these elements, yeah. So if you have k elements, each of these k minus 2 elements should be sum of two previous elements. Yeah. So let's mark them as good elements. So let's say element is good if it is equal to sum of two previous elements. So if I have if all these elements are good, yeah, yeah, and I have let's rename it. Let's say k. So it's okay. It's named C in my program. So if I have C good elements in a row, then I have sequence of size C plus 2. Yeah. So I have two any element here and plus C good elements here. So that's what I'm doing. I'm trying to find the maximal number of consecutive elements which are equal to sum of two previous elements. Yeah? So that's what I'm doing here. So here I check if element too fast. Let's see. So I check here. So I check if element is equal to sum of two previous elements. Yeah, I increase this number C. So C is just length of this sequence. Yeah, and if it's not, I erase this number, so I make C equal to 0. So I just clear the counter and then start from the new counter. Yeah? And every time I increase the counter, I update my answer. Okay, nothing very fancy in this problem, but we get a nice, interesting problem actually. Let's move to problem D. Problem D is also not very okay. Not very interesting, I would say. But again, the interesting part of the problem is to do it in good time complexity. So you need to do it pretty effective to fit in the time limit. What you need to do is to find each point in every direction, find number of points which have at least one person in this direction. What I will do? Let me show. I will do it like this. So consider So consider direction to the left. So if we're looking in the left, yeah. So the position is good if we have at least one person in this direction. One person, what? At least one actor in this direction. So if you consider some row of this table, yeah, so you have some 0, 0, then 1. So everything to the right from this one are good positions. So all positions here are good position. Yeah? So what I will go? I will go from left to right. And when I see 1, I remember then all next positions are good. Yeah. So if I see any 0 to the right from this one, I make +1 to my answer. Yeah. And then I will do the same in all four other in all four directions. Pretty straightforward, but again, you need to be careful to implement this again. And I will copy the code 4 times, so we need to be extra careful. So I try to do it without any mistakes, because when you copy it 4 times, you have 4 mistakes. Yeah, don't do it. So let's see that. So okay, stop. So this is this one I'm using. Okay? So I go for each row. For each row, I go from left to right. See, when I see 1, I make OK equal true. Okay, means I already saw at least one actor. Yeah, and if I see 0 and OK is true, I will increase my answer. Yeah, yeah. So that's how. So this line basically increase the result if OK is true. And then I just need to copy this code multiple times. Yeah. Now I do the same from right to left. Okay. So I consider every row left to right and right to left, and then I copy it two more times and do the same for the columns. Again, I'm not very proud of this code. Probably I should. So if you want to make beautiful code, you have better ways to do it. But again, the task here is to implement it as fast as possible. And if you have code like this, so I have this is pretty small block. You see, like how 1, 2, 3, like 10 lines of code. Yeah. If you copy 10 lines of code, you have 40 lines of code. 40 lines is not very scary. If you have 100 lines of code and you copy it you have 400 lines of code. That's not what you want. Okay. So 40 lines is kind of okay. 400 lines, it's not very okay. Yeah. So again, it's always a trade-off between making a beautiful code and implement it fast. Yeah. So here I kind of want to implement it as fast as possible because I want to move to the next problem. But okay, in some another situation, I may consider simplifying this code to make it shorter. Shorter code has less bugs usually. So that's how I solve problem D. Just solve in one direction and then copy it and solve it in all four directions. Okay. Let's go. Problem E. So I didn't write anything in problem E, so let me write you something. So what's happening in problem E? So I can do it without paper, but if you don't do it without paper, so what's happening here? So we have A modulo X equal B. Yeah. What does it mean? It means that A equals B plus X multiplied by some number K. Yeah. For K is integer. Yeah. And K is greater or equal 0. Now let's look at this part. So this X multiplied by K. So X multiplied by K. So you move this to the left. X K equals A minus B. Yeah. So it means that number X must be divisor of this A minus B. Yeah. So numbers are pretty small, so up to 10 power 9. Yeah. So all we need to do is to find all the divisors of this number. I call it number C. So you can find all the divisors of number C in time complexity square root of C. Yeah. So if it's 10 power 9, it's enough. Yeah. So that's what I stop. So I'll find all the divisors. Also, you need to check that the divisor X must be greater than B. Yeah. So you need to find all the divisors of number A minus B, which are greater than B. That's it. That's the whole problem. There are some special cases. Usually I consider special cases first. So I consider special cases and then general case. So special case A equals B. Then you have infinite number of x's. Any big x will work. Yeah. So your answer is infinity. another special case if is b greater than a. Then you have just 0 cases. I think it will. No, it's not. So okay, I will want to count divisors of divisor of a minus b. If a minus b is negative, it may be tricky. So I want this a minus b be positive. So now a minus b is positive. So I consider a minus b. I rename it to c because I normally have d as a divisor. Yeah. So here I'll find all the divisors of number a minus b. No, I normally do it like this. Here I forgot I need to check that divisor is less than b, but great. So here, that's how I count divisors. Yeah. So I iterate all numbers less than square root of c. If it is divisible, I increase number of divisors. And here I check that I have different divisors. So I have pair of divisors d and c divided by d. Yeah. Okay, let me show you. Sorry, if you never saw it before, I don't have a lecture about this, so yeah. So for so I iterate over numbers from 1 to square root of c. Yeah, and I have a pair of divisors d and c divided by d. Sometimes I have the same divisor. Yeah, it happens if d equals okay, if d equals c divided by d, means that d square equals c. Yeah, let's move this d here. So that's what I check here. Yeah. So here I check that I have a pair of non-equal divisors. Yeah. So if I have two divisors, I increase the result twice. Okay, here I forgot I need to check the divisor. Okay, I will do it now. So okay. Okay, you also need to check if the divisor is big enough. So if it's greater than b, so I check the divisor as b, and here I check the divisor is greater than b. That's it. That's the whole solution. Yeah. Now let's go to problem F. Oh, okay, here I misclicked and open problem G instead. So first I solve problem G and then move to problem F. Let's follow this. So we'll discuss problem G and then discuss problem F. Problem G is kind of okay. So a lot of things happens in this. So first you read this problem and think, okay, what the hell is going on? So let's stop here for some time and just discuss what's happening here. So after you read this, you think, okay, what the hell is happening? So I have two operations. So I have two. Okay, let's try to eliminate everything which is not important. So I have two parameters. They call HP and the damage for some reason. Okay. So I have two operations. I can increase HP and I can assign my HP to my damage. Why? We don't know. Yeah, so it's strange operations, but okay. Now, what we need to optimize? We need to maximize the sum of all damages. Yeah, so maximal total damage. You see here. Why? I don't know. But you don't think why. So you just solve what problem you're given. So now you see. Okay. So okay. I want to increase my total damage. Let's look at our operations. What's happening to the damage? I can increase, but my health, not the damage. Yeah? For how I can change my damage only by assigning this health, this HP to my damage. Okay? So this is the only operation which can possibly increase my total damage. So how could I increase my damage? No, I first need to apply this operation several times. So I have some values of HP for some creatures. Okay, for some creatures I increase their HP and then copy this HP to the damage for some creatures. Yeah, and I want to maximize the total damage. Okay. Now let's move to the whiteboard. So that's what's happening. Yeah. So you have some value of H. let's say for HP, yeah, H and D for simplicity, yeah. So what I will do, I will multiply by 2 some of them. Let's say multiply this 3 times, multiply this 2 times, and then copy some of these values to D. Like this value, okay, it doesn't make sense to increase it and don't copy, yeah? So I increase some of them and copy. And then I can copy some of them without increasing. So I copy some of them. And what I want to do, I want to maximize total sum of elements here. Let's do it one by one. So if we cannot increase, so if we just copy the elements, if we just copy these elements and we can't increase them, if we can't increase them, just copy, then what you will do, what is the optimal answer? Again, this is something I do a lot. So when you have some problem, you want to first simplify it. So solve more simple problem. Just if you have only 2 operations, just remove one of them, solve with 1 operation. If you cannot solve this 1 operation, there's no way you can solve it with 2 operations, right? So let's try add complications one by one. So first, let's consider only the second operation. If I only allowed to make the second operation, only copy my HP to damage. So what I need to do, I need to pick the elements with maximal difference. Yeah, so I need to copy elements with maximal difference of HI minus DI. Yeah. So I pick element with maximal difference, which will increase total sum by the maximal possible way. Good. Okay, this is something I can do. Yes, I can take all elements, sort them by this parameter, and take some number of these elements. Yeah, but some prefix of at most B elements from the prefix. Yeah? Okay. Now let's add complication. So now we allow ourselves to increase some elements twice. Yeah. So what we'll do, if we already pick some element, so what we'll do, we can take the element and increase it. So we will multiply by 2 a couple of times. Now let's keep on only first operation. Imagine you copy all elements and think only about the first operation. Yeah. So you have some elements and you can double some of them some couple of times. Yeah. So what is the optimal way to double elements if you know which elements you have? No, it's kind of makes sense. Yeah, if you think about it, to double the maximal element. If you want to maximize the sum of the elements, you always want to double the maximal element. But if you double the maximal element, it will still be the maximal element. So in any configuration, you only apply this operation 1 to the one element, to the same element. Yeah, it doesn't make sense to apply first operation to different elements like here. It would always be better to move this 2 to here. It will always be better. Again, what I'm doing, I'm trying to simplify the problem. Yeah, so I'm trying to eliminate all configurations which will not lead me to some optimal solution. So you want to eliminate all non-optimal configurations and only think about potential optimal configurations. Yeah, and just limit yourself to this set and then think what will you do about this set. Now, again, in my optimal configuration, I know that I take one of the elements, and double it 8 times. After this, I take elements with maximal difference and copy them to array D. Now, this set of elements will not change that if I pick this element. So I can iterate over each element. So pick element I and see what will happen if I double it 8 times. Yeah. So one of the elements, so I pick element I and just assign hi equal hi multiplied by 2 power a. Yeah. After this, I need to take at most b elements with maximal value of this difference and copy them. This set will be almost the same. So it may change by at most one element. So I will first calculate this set without this change, and then try to change every element and find how this set is changed. This changed not that much. Yeah. Okay, so this is the whole idea. And now I try to implement. My implementation is not very nice actually, and I spent too much time debugging it. You'll see. So let's. Okay, so here I'm sorting. Okay, here I'm sorting the array by this difference. So I want my first element. So some prefix of this array will be the elements I want to pick. So I pick at most b elements. So I go to elements maximum n and b and check if this difference is positive. Yeah. So I pick this element only if this difference is positive. So I go because now I will mark all the elements I pick. So this marks G. Mark the elements in this set I want to copy from H to B to D in the end. Yeah, if I don't change anything. Here I have a mistake. I need to pi second. I will fix it later. Okay, here. So what I did here. So I didn't. So I'm doing only the second part. I only try to copy the elements without doubling them. Yeah, so you see. So again, I marked all the elements I wanna here. I marked all the elements I wanna copy. I will also find the last element because when I change it, okay, it's for future. I wanna no sorry. So when I pick new element and I wanna double it and then copy it, I need to uncopy one of the previous elements. So here I mark the element which I don't need to copy. It's for future, doesn't matter. So here. I calculate the result here. I calculated the result without doubling elements. Okay? Just and I will run program here just to check that I didn't make mistake by now. Yeah. So it turns out I did. I made some mistakes already. So it's something I do a lot. So when you implement the program, you don't implement it as a whole and then run and then check it, find all the mistakes. You implement some part of it, then run, check that your intermediate result is what you expected, yes, and then continue to implement it. That's for me. It's much more much more convenient way to implement a code. Not implement like all, especially when you have a large program like 200 lines of code. Yeah, that's sometimes it's just what you need to do. Yeah, sometimes any part of this code doesn't make any sense. You implement it a lot as a whole and then run. But usually you can split it into some logical parts, and then you implement first logical part, run it, check that your intermediate result is what you expected, then implement the next part and so on. So here I already made some mistakes, so I found these mistakes and fixed them. It's here, answer is 21. So here, yeah. So this 21 is correct result by now. Yeah. So if you're not allowed to double anything in this first sample, yeah, you have 15 plus 6. Hi. 15 plus 6 equals 21. Yeah. So if I'm not allowed to double elements, 21 is correct result. So I'm okay with this result. Yes, I check the second one also. Second one is correct. Yeah, that's a good start. So now let's double some elements. So here I will iterate over all elements. Okay. So okay. It's important if I get this. Okay. You only do it if you have at least one element to copy. No? It doesn't make sense to double elements if you're not allowed to copy them. So I just protect myself for future mistakes by doing this. Yeah, here I try to take one of the elements and double it 8 times. Yeah, so if I double it 8 times, I get this result HI. So I just use this shift left, yeah, for calculating powers of 2. Check if this result is greater than my current damage, So if this, okay, if it's less, it doesn't make sense to double this element. So it will still not be greater than it. Now I check if I am already copying this element. Okay, I made several mistakes here. So if I'm already copying this element, yeah, I just update the result. Here I made a mistake. You can find it. And okay, if I'm not copying it, I need to copy it and then uncopy one of the previous results. Yeah. So I need to copy my element. And since I am not allowed to copy more than B elements, I need to uncopy the last element I copied. Yeah. So I copy my element, add this difference to my result, and then I undo copying of this element. Yes, and just subtract this difference from the result. Here I made several mistakes. You can find it. Okay, here is 20. Okay, let's find this simple mistake. So simple mistake is 32. Okay, spend some time fucking. Oh, spend too much time here. The problem is was here. It was not d but h, because if I already copying it, I already added difference h minus d to the result. So here I need to add difference between current h. So it's already copying. So I'm counting as h. Yes. So I need to add difference from x to h. Yeah. Okay. Okay. Here, okay. Here I'm starting to read problem F already. So problem G is testing now. Yeah. So I'm already reading problem F and thinking about problem F. Again, that's something I do a lot also. So I submit solution and I don't wait for the outcome. I start reading next problem. So it's already uploaded to my brain and I start thinking in the background. So I spend less time. When I finally move to this problem, I will spend less time solving the problem. Again, now I get wrong answer test number 30, you see? Okay, that's unfortunate. So, okay, I think, okay, I made some mistake. So it doesn't look like integer overflow. It's normally I would think about integer overflows, but I checked, I don't have any integers. Yeah, here I check this difference. So I just checked that I don't have any overflows here. Okay. Here I see I see less equals -1, and I didn't check what happens if less equals -1. So here, so if I didn't copy any elements here, I don't need to uncopy it. Yeah. So what I will do here, let's move. Yeah. So I will see if I copy some elements. So if I didn't copy any elements, I don't need to uncopy it. Makes sense, right? Boom. Okay, here I think about problem F. So I submitted, move to problem F. Yeah. Okay, I get wrong answer, task number 4. Okay, I move back. So let's move back. So again, I spend some time thinking. Again, can you find the mistake here? Okay. If you solved this problem before, so you can pause here and find the mistake. Mistake is actually pretty simple, but I spent too much time thinking about it. The mistake is that sometimes, so see here. So in this part, I copy at most B elements. I don't always copy B elements. I copy at most B elements, but I copy only elements with positive difference. Yeah. And sometimes you have less than B elements with positive difference. Yeah. So here you don't need to uncopy elements. Yeah. So again, so here, you may copy less than B elements. So you copy here. You copy less than B elements, and when you need to copy this element, yeah, you didn't copy it before because it was small, but now we double it a couple of times. Now it is greater, and we want to copy it, and we can do it without changing this, yeah, because we copied less than B elements, because we have less than B positive values. Not very proud of this code, but yeah. So what we need to do is actually to count how many elements we already copied. And if we copied less than B elements, then we don't need to uncopy the last element. So here I will, what I will do, I will count how many elements I copied here. And here I will check. Yeah. So the code is right. This if is wrong. Yeah. So I need to uncopy the element if I don't have any extra operations. So if I copied already b elements, yeah, then I need to undo one of the operations. That was the last bug. So this is the final code. It's not that. So let's copy. So this is the final code basically. That's the whole. It's not very complicated, I would say. So it's like 50 lines. No, not that much. But it's tricky. So problem G is kind of tricky. Let's actually read your solutions. I'm very interested in your solutions. Problem G. So how did you solve it? I have priority queue. So again, you don't make these tricks. You just keep priority queue. Makes sense. That basically that's probably the better approach. Yeah. So you just put these elements in the priority queue and just update it and calculate some on the priority queue. Yeah, that's probably a better approach. So you maintain priority queue again. You want to maintain the set of the maximal differences. And you maintain this set and you update it. Yeah, and you update the set and maintain the sum in your set. Yeah, nice. I like this approach better than mine. Good. Oh, let's problem F. So in problem F, okay, problem F is nice constructive problem. I love constructive problems. I am not very good in this, but sometimes I love them. So here we have pretty simple construction actually. So how do you solve construction problem like this? So what we need to do? We need to find the array with number of good subsequences equal to x. So good subsequence is subsequence with difference between maximal and minimal element at most d, less than d. How would you do it? No, first, okay. What I usually start with? I start with very simple constructions. I try to imagine the simplest possible answer, and okay. So in this case, simple possible array, and just count what is the answer for this simple possible array. Yeah. So the simplest possible array is array of the equal numbers. So if I have array of equal numbers of length k, then any subsequence is good subsequence. Yeah, because difference is 0. 0 is less than d. Yeah, so any subsequence is good. So I have 2 power k minus 1 non-empty subsequences. Yes. So I can take any subsequence and it's fine. So, and now I think, okay, I can repeat the same pattern. So I can take number 1, then take number d plus 1, and these two parts will not intersect. Let me show you. So imagine you put some numbers 1, and then some numbers d plus 1. Yeah. You cannot mix these numbers. If you mix this number, difference is already d. Yeah. So I have some numbers here, blocks, some block like this, then some block like this, then number 2d plus 1, 2d plus 1, and so on, some another block. So every good subsequence only consists of equal numbers because I cannot mix these numbers. And my numbers will, so if I have like k1 numbers here, k2 numbers here, k3 numbers here, then my answer will be 2 power k1 minus 1 plus 2 power k2 minus 1 plus 2 power k3 minus 1 plus and so on. Yeah. Nice. And now I believe there are many possible ways to do it. I just do it greedily. I just go from higher power software to smaller power software and just greedily apply these operations. it kind of makes sense to do it greasily because it will not. Okay, you will have kind of log n, no log of what log x uh, elements in total. Yeah, log n blocks. Yeah. I just do it greedily from higher power to smaller power sum to just make these blocks until I have desired result. Let's keep a little. Yeah. So here, so I'm going from big powers of 2 to small powers 2. I got 32, probably too much. 30 will be great, so it's 10 power 9. Why have to 32? I don't know. So here I check. So C is size of the block. See, I check. Is not the size of the block. Number of okay. I is size of the block. So C is number of subsequences in this block. So I check if this number is greater or equal than D, or less or equal than X. Yes, so I can make this block. So I make this block and decrease. I make this while because I make several blocks. Yeah, like if I have like 2, X equals 2. Yeah, we need block 1 and 1. So it's not like with normal powers of 2. It's power 2 power n minus 1. Yeah, so it's slightly different. So I make this while just to make sure. I'm still pretty sure I will have no more than like log n blocks, and I have 10,000. It should be more than enough. So I'm not very concerned about the size of the result. Sometimes in this problem you need to be careful. So if n is like 10,000, it looks like a lot. Yes. So I probably have like blocks of size at most 32, and I have at most like 60 blocks. It's more than enough. If I have n at no more than like 1,000, I would be more concerned about how amount. I will do it more carefully. Yeah, I will calculate maximal number of elements I will have. But here, 10,000 should be plenty. Yeah. Yeah. Here I just take. Okay. In here I finally submitted and get wrong answer. Can you find all mistakes in this code? Very embarrassing mistakes. Okay. I don't know why it's still happening to me. Okay, I'm doing it for many years. Why it's still happening to me? Okay, let's so we're gonna start from 15. So again, okay. I immediately thought I have some integer overflow problems. So I thought, okay, it should be some integer overflow problems. What else? What else can we do? Yeah? But I kind of read this code and I didn't find any problems. I'm not sure. Maybe I was too tired when I solved this contest, so I didn't pay that much attention to all the details. Okay. Normally, what I will do. I will just make. I will just just find all ints in my code, just using normal search in your in IDE. And just look for all of them. That's what I normally do. But here I decide I just need to read this code. Okay, here I tested it. Okay, here I tested and find, okay, there's something strange happening. So I definitely have integer overflows. Okay, I'm looking where I have integer overflows. Okay, here I have integer overflows. And here I submitted it without even checking. I don't know what's happening to me. So I was already solving problem H at this point. I didn't want to spend time here. Try again. It's really embarrassing at this point, but again, happening. So I see again I have integer overflow problems. Where? And I read this code once again. Do you see where I have integer overflow problems? Very embarrassing at this point. I have when I output the result. Okay, sometimes I'm thinking about again. Some people make define int long. I'm thinking about doing this. I don't know why I'm still not doing it. I don't know. Maybe I need to move. Maybe I need to try to make this define in my template just to not have any problems like this anymore, because it's really embarrassing every time. Let's move to problem H. Problem H is fun. Problem H is fun. So what we need to problem H, we need to find the number. So if we take this number, reverse it, and sum of these two numbers, normal number and reverse number, we get the desired result. Very cool problem. I don't know what the intended solution, but my solution is kind of cool. Uh, okay, okay. Here I spend some time just thinking. So what I'm doing here, I'm trying to think what's happening. So I look at every digit and see what is so how this digit is contribution of these digits to the final sum. Yeah. So I see this first digit and last digit, they sum to the first and last digit of the result. Yeah. So this 2 and 9, they both adds to the first and the last position. Yeah. And so on. So we have some digits. So basically what's happening here, we have symmetrical digits. We only care about their sum. So their sum will make some contribution to the result. Yeah. Let me see. Let me see. So imagine you have some number, yeah, and you have first digit like 3 and first last digit like 5. Yeah. So when you will be, so this is a this when you will reverse this number, you will have now 5 here and 3 here. So when you calculate sum, yeah, we will have 8 here and 8 here. Yeah. So these two numbers 3 and 5, they contribute to this digit and this digit. Not this position, this position. They may have overflows. Yes, also again, if you have number, if this sum is more than 9, you will have this overflow. You have these carrying bits and stuff. We will go to it later. Yeah. But the idea is that these two digits, they contribute in the same positions. Yeah. And basically, we only care about the sum of these digits. Yeah. So if we put another digits with the same sum, let's say like 1 and 7. Yeah. And here we have 7 and 1. The result will be the same. So we don't care about what digits we put in these symmetrical positions. We only care about the sum of these digits. Yeah. So if I look at the first digit and last digit, so I have, let's say, put digit x and digit y. Yeah. I only care that sum of x plus y is between 0 and 18. So 18 is the maximal sum of two digits I may have. Yeah. So what I will do, I will try the sum of this x1 plus y. And if I know the sum, I can always split the sum into two digits. So any number between 0 and 18 can be split into two digits. So I will find, so now how to find this sum? That's an interesting question. So again, let's look at the result. So let's look at the last digit of the result. So imagine you have digit, okay, let's put some other digits. 8 is not too fun. So let's look at the last digit. Imagine you have, so this is the sum. So imagine in the result you have some digit, I don't know, 3 in it. Yeah. So how did you get integer 3? There are just two options. So you may have some digit like 1 and 2, which give you some 3. Or you may have some digits, let's say 9 and 4, that will give you some 13. Yeah. So if the sum is 13, you still have the last digit equal to 3. Yeah. So you have two options, basically. So some of these digits may be 3 or they may be 13. How to choose between these two options? That's a good question. That's a good question. What I was thinking. Okay. Let's so now we limit ourselves to only two options. That's good. Two options is more than, it's better than 18 options, 19 options. Now we have only two options. Let's go to the left part. So in the left part we have, so now I have, okay, so this sum also should be either 3 or 13. It should be kind of easy to distinguish these options here, because this left position contributes to the sum a lot. Yeah. So I can just look at these positions in the sum. So if it is 3, then this part will be either 3 or 4. Yeah. Because this everything to the right can contribute to this position only by carrying bit. Yeah. So if it is 3, then the first digit will be 3 or 4, no more. Yeah. If it's 13, it will be 13 or 14 here. So the difference is a lot. It will be very easy to distinguish these two cases. Yeah. Okay. So that's what I was thinking. So I will find this remainder modulo 10 of the last part, and then check these two positions, check which one to take. Yeah. And I will do it by looking at the left part. If left part is big one, basically, yeah. So I will take the big one. If it is small one, I will take the small one. You will see how I did this. Okay. So I implemented in some cheaty way, I would say, but you will see. Let's go. So here I'm okay, so here what I'm doing, I'm just writing this stuff and just thinking of what's going on. And here I finally noticed that I have one in the right position. So here I'm saying that I have these numbers, I multiply them by something like this. And I see here in the right, I see I have all zeros except this. Yeah. So this number will contribute to this last digit. Yeah. Okay. And here I also noticed I have something strange in the middle. I have this middle digit multiplied by 2. So it need to be it need to be tracked differently, but this middle digit is different. You need to you need to make some special code which deal with this middle digit. Okay, it's okay. I'm just okay. Okay, it's hard to watch myself thinking. Okay. Okay, here I go. So this case when I have odd number of digits, they have even number of digits. Here's kind of the same. Yeah, so I have the same, but I have 2 digits in the middle. Again, I will deal with them when I go. So let's go. Oh, yeah. First, what I'm doing, I need to figure out what is the length of my number, because the length of my result will kind of to tell me which pairs of digits I have. And I think you can, yes, I think you can do it easily. Here I just take 2 steps. So if you sum 2 numbers of k digits, you will have no more than k plus 1 digit. You will have either k or k plus 1 digit. Yeah. So so if n is size of my result, then the size of my number should be either n or n minus 1. And here I'll just try both cases. Okay. So I'll fix the length of my number so I know which pairs of digits I need to consider. Okay. Skip it. Here, what I'm doing here, let me show you. So what is my plan? So imagine I already know the result. So this is my number. I will move from left to right and from right to left. So this number will be L, this number will be R. So L and R are indices of my digits. So this is my sum. So this is my number A. This is my number A plus AR. Yeah? So these LL and RR are like additions to these digits by these carrying bits. You'll see. So L and R are positions. Here it's not a -1. Here I have a mistake, so I'll fix it. And these are kind of additions to my number. So if I have one extra digit here, I know. So like if I have 1 here, yeah, then I know this position should be not x but x plus 10. Yeah, so I add this to the result. Okay, no, that's LL. Okay, so LL and RR are additions to these current digits. Tricky code, actually. I believe it should be. It can be done easily, I believe. So here I calculate my left and right digit. Yeah. Considering these additions. So LL is addition to left. So LL are my current left and right digit. Now I look at my right digit. Calculated modulo 10. I have plus 20 because it may be negative. Probably plus 10 should be enough. Yeah, I'm just to be sure. Yeah. So yeah, it may be negative if I put. So let's say if I put. So in the last position I put something like again something like 9 and 4. So here I have 3, and I have 1 carrying bits. but in the result I have 0 here. Yeah. Yeah. So you need to get 0, but you already have one extra bit. Yeah. So this number should be kind of -1. Yeah. But it's -1 just means you can it must be 9. Yeah. So you put like 4 and 5 to make it 9. Yeah. Put 9 here plus 1 kernel bit. You have 10. Yes. And you move this kernel bit here. Something like this. So this x may be negative. So just to make sure I calculated modulo 10 normally. Yeah. Oh, yeah, this is the cheat. So I need to distinguish two cases when I have x and x plus 10. That's how we do it. Yes. I check if the number on the left is greater than x plus 5. So it's something in the middle. Yeah. So it should be either x or x plus 10. I'm not sure about plus minus 1, but x and x plus 10 are far away. Yeah. So I just check in the middle. So it should be far away from x or from either x or x plus 1. It's okay. So now I know. So now I thought about it later, and now I think it should be either x or x plus 1 or x plus 10 or x plus 11. Yeah, something like this. So it's, but here I didn't think about it that much. So I know it should be not far away from x or not far away from x plus 10. Yeah. So I think x plus 5 is good middle point here. So I check if number is greater than x plus 5, it should be x plus 10. Okay, here. Okay. Oh, here I thought about how could I calculate the result. I do it like this. Not very good way actually to do it. So I put the result in the string and then I'll put the string. Now I think it's not very convenient. I have different size of this string, so I have okay. So it's not very fun when I have okay. So my string s is maybe longer than my result. Then I have different indices. I don't like this. So I make it the same. Okay, it should be s size here. So I want to make it the same size as the initial string. Yeah. It might have some extra character in the beginning. I will just fix it in the end. Okay. You're right. I'm trying to put like so if this x is not in range from 0 to 18, it means it's impossible. It's impossible to put this sum in this position. So I just stop. Okay. If it's not, then I will try to put this sum in this position. I will split this sum into 2 digits. So like I told you, so any number between 0 and 18 can be split into 2 digits. I do it like this. Okay. Nice way to split, yeah, you see. So if it is small, I just make x and 0. If it is large, I have 9 and x. So I maximize the first digit and the second digit. It kind of makes sense because I want to avoid leading zeros. Yeah. So I want to find the left, I want to make the left digit non-zero, if possible. I think in some sense I build the maximal possible number. Yeah. And also I update my left and right additions. So in the left I see, so I put number x, but I want to have number L. So something may be left. So I take this extra and multiply by 10. It shouldn't be greater than 1. So this number should be at least at most 1. It may be 0 or 1. If it is 1, I will have 10. So I add this 10 to the previous digit. Yeah? And the same from the right, but I will divide by 10. So I calculate this difference again and just divide it by 10. So I want to have r, but I have x. So I take this difference and I want to get this difference to the next, just move it to the next position. Yeah. And again, when you move left to right, you multiply by 10. When you move right to left, you divide by 10. Okay. Tricky code. Oh, here I was afraid I will have some integer overflow, so I do it like this. So if I see this left difference is already looking suspicious, so if it's greater than 1000, I definitely will not compensate it. I believe it cannot be greater than 10. You can put 10 here. Yeah. Yeah. Here, just to make sure. So I'm kind of sure. So you can put any number here. Yeah. You just make sure you don't have integer overflows here. That's what I was afraid. I was afraid of integer overflows in this position. That's why I put some check here. So I want to check it in the middle. So if it's in the process I have a large number, I just stop and say impossible. Yeah. Because it may add up, and in the end you have integer overflows. So I do want to stop it in some point. Here, yeah, here I'm dealing with the middle. So in the middle, I have two situations when I have one digit in the middle and two digits in the middle. And I have one digit in the middle. I just check what digit I have. I check it if it is it should be even because it's a digit multiplied by 2 in the middle. Okay? I just find this digit and put it in the middle. If I have two digits, again I find the sum. Okay, so I take the left addition, right addition, multiply this by 10. So this is my sum of these two middle digits. Yeah, and just check. So this middle part will be multiplied by 11. Yes, in the middle. So let's say do okay. Here I just think why I have one digit here but two digits here. No, because let's say yeah. No, that's it. If everything works, then I just output the result and exit. So when I found the result, I immediately exit from the program. Looks okay. Then I just type 4 and nothing happens. So I think, okay, what the hell happening? Um, okay, here I see that the result is empty. It shouldn't be empty. It should consider one. It should be one character. Actually, why it's empty? Go to the bench because here I have not assets. Yeah. Nothing much to tell about this. Sure. Okay, now I try in two-digit number. You see 18. So okay, so this works fine. 18 didn't work. Yeah. So I want to try 9 plus 9 equals 18. So I start with small tests. I start from here, check what's happening. And I think, okay, why I'm going here? Why I'm going here? Okay, because I start from low position. This R should be n minus 1. Because it will be SS. Okay, it's because my bad indexing actually. Not okay, not the great code. So my indices are not in the result string but in the initial string. So not like this. So it's okay. It's either from 0 to -1 or from 1 to n. So doesn't matter. You see, and then I have this extra dot because I want to have I want all the digits to be aligned. So I just add this extra character. If my result is shorter than my initial string, I just want this extra character so they align correctly. I will just remove it. Yeah, like this, why not? And now I will submit it, and I will have wrong answer test number something. Okay, I just tested. Uh, can you find the mistake by now? It's actually a fun mistake, non-trivial mistake at all. Let's see some. I just test some more tests. I just again what I'm doing here. I'm just trying to run some different tests. So I know I have two different cases when I have odd size and even size. So I just try different case of odd size and even size with some carrying bits and stuff. So we just try to run some tests which uh, use different parts of this program. Yeah, because I have like in this I have different cases. So I run tests which just test different parts of this program. And they all work. Yeah. So all the test passed actually. I right. So it doesn't look like a simple mistake. It looks like interesting mistake. So I'm thinking what wrong what can be wrong in the program. I just check this, check this, and what I noticed that I need to again I need to get number without leading zeros. Yeah, see, and I never checked that I don't have leading zeros because I kind of thought that it's impossible to make leading zeros. Yeah, no, because how can you get leading zeros in this program if you didn't have leading zeros in this sum? So when you try to pick the first number, yeah, it shouldn't be zero because yes, because then you call zero in the sum. But here I thought, okay, maybe I'm wrong. So maybe it's possible to get the number when with leading zeros, and I'm not well here. And here I finally find this test. So if I have leading zero and I have carrying bits, then I will have not zero in the sum. Yeah, here you see. Yeah. So this 120 is, so if I'm allowed to have leading zeros, I have 0, 9, 0. I reverse it, have 0, 1, 0, 9, 0, and I have 180. Yeah. So that's something which is not allowed, but I never checked it. And I will just add simple check. I will just not put leading zeros. Yeah. So here I check if I'm in the last position, I'm not allowed to put here. I'm just not allowed to put 0. And I believe that's it. Yeah. Okay, so this is the whole solution of problem H. Not sure if it's the best solution. Let's check your solutions actually. Okay, we have two people solve problem H. Let's look. Oh. We have some dynamic programming, right? Yeah, we have dynamic programming. I was thinking about dynamic programming. I was thinking about, but I was not sure how to implement it correctly. Okay, so we have dynamic programming of 4 position. Interesting. That's a lot of code. Okay, here we try all the sums. Check if the sum equals to what we need. Okay. I was thinking about dynamic programming solution, but I don't know how to deal with. No, basically, so you go from both ends, right? Again, you can do the same. You go from both ends and try to add these numbers. But again, you try to all numbers. Okay, you don't have this hack like I did. So you don't you try both variants. Yeah. So when you have like 3, you try both 3 and 13, and kind of process both operations, move to the next state of the name program. Yeah, good plan. No, why not? Okay, in this in these 2 bits, you remember if you have these carrying bits from both sides. Yes. Okay. Okay. And here we deal with the middle part. Nice problem, right? No, I like my code better here actually, but yeah, good for you solving this problem like this. Nice. If you manage to write this amount of code and debug it successfully, good for you. Let's check Alexis. Oh, it's actually pretty short. Interesting. Strange code formatting, not okay. Who am I to judge? Okay, may I reformat it? Okay. It's actually okay. That's a good plan. That's what I should do. Yes. So you have string, but instead of, so string is not very good object for doing here. You immediately move from string to array of integers. That's good thinking. That's what I should do. I was too lazy. I shouldn't be. So because you have, okay, I didn't make any mistakes this part, but I could make mistakes. And yeah, so string is not a good object to process numbers. Yeah, it's just much easier to move from string to just array of integers. And here what you're doing, you move these bits from one register. So what you can do, you can decrease one of the number and then increase this number by 10, and like effectively having the same number. Nice, love it. It's actually much better than mine. Yeah. So that's how it should do it. Yeah, and then you can apply this operation. And okay, I love this program. Let me show you what. Okay, I'm not sure if I understand correctly what I was doing. Okay, let's have some example. Let's have some example here, like have 3, 14, 9, something like this, plus 9, 14, 3 equals what? 2, 9, 12. Yeah. Yep. So what you doing have here? You have number. So you have like 4 digits, and you can move digit from one to another. So you can take this 1 and move it here by making 0 here and making 12 here. Yeah. So basically apply this operation of moving 1 from one position to the next position. And here you just want to make these two numbers equal. Yeah. So you take this number and move 1 from here. So you make this 8 and move 1 here. And you want to have basically palindrome in the end. So apply this operation and try to make palindrome in the end, and making all numbers in range from 0 to 18. Yeah, makes sense. It makes actually a lot of sense. 10 or 18 and smaller than 10. This looks like some cheat. So if difference equals to 10, okay, if difference equals to 10, I definitely need to do this. If difference is equals to 11 and right number is less than 10, okay, because I got it. Then I do it again. Okay, I got it. If not equal, then it's. So I'm trying to make the first and last digit equal by applying this operation. If I cannot, then there's no solution. And where you deal with the middle, you still need to deal with the middle, right? No? You don't have special case in the middle? Ah, here. Okay. If you're in the middle, you just don't make these ifs. Okay, makes sense. Because SL will be equal to SR if you stand in the middle. If you stand in the middle, just do this and then. And just make this. Okay, nice. And when you split this digit into 2, you don't need to. You need, no, you need to split your digits. You just divide by 2. Yes. You divide like this. You make half, you put half here, half here. And make bigger half on the left so you don't have leading zeros. Nice. No, I like this solution actually more than mine. Good for you. Good for you. Nice solution. So that's it. That's contest 22. Thank you for watching me today. See you next week.